Hello friends, in this video lecture, we'll be talking about the concept of entropy in theory. In this example, we are considering the case of a closed system undergoing an irreversible process. When I say a closed system, it means no exchange of mass in or out of the system. For example, the mass of gas enclosed in the piston and cylinder arrangement. So, in this piston and cylinder arrangement, we already have certain amount of gas and no gas can enter or exit the chamber. What can be the change in entropy in such type of system if the process are reversible or irreversible? In thermodynamics, we have studied the concept of reversible process while learning the basic concepts, and it is defined as quasi-static process. If one want to get the feel of a reversible process, can definitely go through the concept of quasi-static process of thermodynamics. Reversible process means the compression or expansion of piston and cylinder in infinitesimally small steps, which is also a very slow process. Irreversible process means the actual process of compression and expansion of piston and cylinder. So, theoretically, for closed system undergoing any kind of process, reversible or irreversible, change in entropy can be written as del S greater than or equal to integration of del Q by T. Here we have not written dq, but instead we have written del Q. The only reason The only reason for this is del Q represents an inexact differential, which is also means capital Q, that is heat supplied or rejected, is a path function and not a point function. Whereas if we write dq, then it is an exact differential, which means Q is a point function, which is not true. From the above equation, we can write two independent equations, one for reversible process and another for irreversible process. For reversible process, we have shown that del S is equal to integration of del Q by T. Whereas for irreversible process, we have shown del S is greater than integration of del Q by T. We can get rid of this inequality sign for irreversible process by introducing the concept of entropy generation. So now we can write the equation as del S is equal to integration of del Q by T plus entropy of generation. So here entropy generation for reversible process will always be equal to 0, whereas entropy generation for irreversible process will always be greater than 0. If we want to categorize the process as reversible or irreversible, we just need to calculate the value of entropy change of a system. If change in entropy is equal to 0, then the process is reversible. Whereas if the change in entropy is greater than 0, the process is irreversible. If the change in entropy is less than 0, then that process is not possible. Now we will discuss the two possible cases of heat interaction with the closed system in irreversible process. In case 1, we will consider when the heat is added to the closed system. In this case, del Q by T will be positive since according to the sign convention of thermodynamics, heat added to the system is considered as positive. The entropy of generation will also be positive since this is irreversible process. In the equation, del S is equal to del Q by T plus entropy generation, both the terms on the right hand side are positive. Hence, the change in entropy will always be positive for such process. Positive value of change in entropy means the entropy increases for the system undergoing an irreversible process with heat addition. In case 2, when heat is removed from the system, the term del Q by T will be negative, since according to the sign convention of thermodynamics, heat removed from the system is considered as negative. However, the entropy generation will still have the positive value since it is irreversible process. So again, in the equation of change in entropy, we have one term that is del Q by T as negative and another term that is entropy generation as positive. So in this case, the change in entropy may have the values as 0, negative, or positive. It completely depends upon how the term del Q by T and the term entropy generation balance each other. If If del Q by T dominates, then the entropy change will be negative. If the term entropy generation dominates, then the entropy change will be positive. And if both the terms balance each other, then entropy change will be zero. It means when the heat is removed when the heat is removed from the system and the process is irreversible, the entropy may increase, decrease, or remain constant. Let us consider one more case when the process is adiabatic. Adiabatic process means no heat is transferred from the system to the surrounding or from the surrounding to the system. It also means del Q is equals to 0. So the term del Q by T will also be equals to 0. Whereas entropy generation will have the positive value if the process is considered as irreversible. So in adiabatic process, the change in entropy will always be positive and it will be equal to the entropy generation if the closed system is undergoing an irreversible process. So from the above discussion, if a closed system is undergoing an irreversible process and if it is not clear that the heat is being added or rejected from the system, we can definitely state that the entropy of the system may increase or decrease or remain constant. I hope you got the idea about the concept of entropy applied to a closed system performing an irreversible or reversible process. Thank you.